All right, now let's solve this advanced level question on units. Okay, they gave us this question. They said, find the units of gravitational constants. Find the unit of gravitational constants. All right, now solution first. Now we are asked to find the unit of gravitational constants. So the first thing here is to write down the formula of gravitational constants. The only formula we can get gravitational constants is on gravitational force. And the formula is this. The formula for gravitational force is this. That is F is equal to G N1 M2 over R square. Okay, remember this formula? Where F is gravitational force, G is gravitational constants, M1 is mass 1, M2 is mass 2, R is radius. So now for us to find the unit of gravitational constants, is for us to make gravitational constants the subject of formula. So let's make gravitational constants the subject. Doing that, we have this to be Gn1 M2 is equal to F R square. Please take note. We cross multiplied. So I will divide here by what is attached to G to make G to stand alone. I will divide here by N1, M2. So the law of equation states that whatsoever you apply at the left hand side, you also apply it at the right hand side. So this will be over N1 over N1 M2 plus this divided by this. I'll be left with G is equal to F R square over N1 M2. So let's write down the units one by one. So the unit of force, we have already done that in part 1. Okay, in case this is your first time to view this, you can view or you can get our video on units and dimension part 1. Okay, so write down the unit of force, that is kg meter per second squared, times this. Remember, the first thing whenever you are calculating for units, the first step is to write down the formula of that quantity you are asked to calculate the unit. Okay, now the next one is to reduce the formula to its fundamental quantity. So this one here, we already know the unit of force, that is kg meter per second square. Now this one here, this radius here can be classified as a circular distance. Radius in a layman understand is a circular distance, though mathematically is a point from the center to the circumference. Okay, but in a layman understanding, radius is a circular distance. Please take note. So if radius is a circular distance, that means it can be classified as distance or can be classified as length. Please take note. So the unit of length is meter. But remember that this particular radius here is affected by square. That is, the power is being affected. So I will write this unit to be meter or square. Please take note. Over class. We only have one mass. You see that called mass. There's nothing like in the fundamental quantity, we only have one mass. So we don't have anything like mass 1 and mass 2. So this mass 1 is the same as mass in fundamental quantity. This mass 2 is the same as mass in fundamental quantity. So the unit will be kg times kg. Please take note. Remember, we don't have anything like kg1, kg2. So they are all kg. Please take note. So the kg at the numerator, we cancel the kg at the denominator. So this will cancel this class. Okay, I'll be left with this. This will be g is equal to meter per second squared times meter squared over kg. Please take note. So let's first of all simplify the numerator. Remember, there's a law that states that whenever we have two bases, we apply indices law. So there's a law that states that whenever we have something like this, whenever we have a raised power of m times a raised power of n, we take one base and add up their powers. So this will be a raised power of m plus n. So whenever we have two letters that is the same, we take only one. Please take notes and add up their powers. So if you look into the numerator here, we have n, we have m. So I will take only one and add up their powers. But before then, please don't forget there's an invisible one here. So I will have this to be g will be equal to m raised power of 1 plus 2 per second square over kg. Please take note. Okay, so when you simplify that, I will have this to be meter raised power of 3 per second squared over kg. So the law of unit is this, that whenever you're expressing any unit, you always express the unit in a linear form, not in fraction. Please take note. So now let's express this unit here in a linear form. To express this in a linear form, I have to take kg from denominator to numerator. But there's a law that states that whenever you are taking anything from denominator to numerator, that the sign of the power will change. That is, if I have something like this, that is from the law in mathematics. If I have 1 over s is the same as s raised power minus 1. So whenever you are taking anything from denominator to numerator, the sign of the power will change. The same thing here, whenever you are taking anything from numerator to denominator, the sign of the power will change. So there's an invisible plus 1 here. So I want to take the kg from denominator here to numerator. It will be equal to class per kg meter raised power of 3 per meter square. Please take note. This is my answer here. The reason why we position this kg as the first here is to arrange. Remember, we always arrange the units in order of their fundamental quantity. We always arrange units in order of their fundamental quantities. Please take note. So kg will appear before meter, meter will appear before second. All right, let's solve this question here. Okay, now the question said, find the unit of viscosity. Find the unit of viscosity. Solution. Now, this is the formula form. The first step here to take, the first step here to take is to the first step here to take is to write down the formula, and after then we reduce the formula to its fundamental quantity. Okay, now the formula for viscosity is force over area times velocity gradient. Okay, now let's write down this formula step by step. Okay, the first is force, and the unit is kg meter per second square. Please take note of this. Okay, the next here is area. Area is length times breadth, and length is a meter times this breadth here can be classified under meter because it is not mass nor is it time. Please take note. Now for those confused, please, all you have to do is to watch the part one of this video before you can understand this particular solving. Okay, so the next is to express breadth is meter. Okay, writing that we have meter. Okay, writing that we have meter. So we see that whenever we have um any expression in two bases, that we use indices to evaluate that. Okay, now we have this to be in two bases, that is m, and we have to take one and add up their powers. When you do that, we have this to be m raised to power of 2. Please take note. So the next is velocity gradient. Velocity gradient. Okay, now velocity gradient is equal to displacement over time. That is for velocity. Now the word gradient means that the formula or the quantity is divided by length. Please take note. Anything attached to gradient means that that particular formula is divided by length. So because of this word gradient here attached to velocity, I will divide the formula by length. Please take note. So the unit is this, meter per seconds over meter. So we know the unit of this, that is meter per seconds over meter. Okay, so when you do that, this is the same thing as this, as meter per seconds in a linear form over meter. So the meter here at the numerator, we divide the meter at the denominator. So our velocity gradient will be equal to per seconds. So we have known the unit of force, we have known the unit of area, and again we have known the unit of velocity gradient. So now let's impute the unit into this particular formula. Okay, All right, now let's impute the unit into this particular formula here. We have this to be viscosity eta is equal to kg meter per second squared over meter squared times per seconds. Please take note of that, okay? So let's simplify this class. Of course, there's meter at the numerator here and there's meter at the denominator. This will cancel this. When you do that, eta, that is the viscosity here, will be equal to class kg per second squared over meter per seconds. Now, there's something you have to understand here in terms of units. Please listen to me carefully. There's something you have to understand here in terms of units, that whenever you want to express the final answer of any unit at all, it must be expressed in a linear form. That means you have to take anything at denominator to numerator. So doing that, I have to take this guy here, that is our denominator to numerator. Remember, whenever you are taking anything from numerator to denominator, the sign of the power will change. So when you do that, class, when you do that, we have something like this. Eta is equal to kg. Taking this guy here, meter, from denominator, to numerator is going to be per meter. Now we already have per second squared. Now taking this one here from denominator to numerator is going to be times seconds. Of course, there's a law that whenever we have two bases, we take only one and add up their powers. These guys here are repeated, so we have to take only one and add up their powers. So this is going to be kg per meter, kg per meter. You take only one, you add up their power, that's minus 2 plus 1. There's an invisible one here. So I will have this to be kg per meter minus 2 plus 1 give us minus 1 per second. So this is our answer here. So all you have to do to get the next video on dimension, that is calculation on dimension, is to hit the subscriber button. Okay, thank you.